Welcome student, I am Mr. Abhijit Bambre working as assistant professor at Gokhale Education Society's Arts, Commerce and Science College, Jowhar. Welcome you again. In last video, we are started with chemistry paper 1 unit 2 that is atomic structure. In that we discuss a Dalton theory and in general atomic structure. Today we are going to discuss discovery of electron, that is cathode rays, given by the Sir J.J. Thomson in 1907, and Rutherford atomic structure. What is Rutherford atomic structure and discovery of electron? Let's move. Discovery of electron, history of the atom. Sir Joseph John Thomson founded that the atom could sometime eject a far smaller negative particle which he called as electron. He founded that the atom could sometime eject a far smaller negative particles which he called an electron. It is a cathode ray experiment. Capital A is denoted by alpha, B means gamma, C means beta. High voltage battery, anode and cathode, negative and positive charge. There is two terminals. When Sir J.J. Thomson's study discovery of electron, he studied of a cathode rays resulting from a electrical discharges in a highly thin gaseous lead to the discovery of electron when an electric discharge is passed through a tube containing a gas at a very low pressure. An invisible spectrum of rays called as cathode rays is emitted to the surface of cathode, which possess certain characteristic suggesting that rays are made up of a minute negative particle, and that minute negative particle are called as electron. Sir J.J. Thomson studied the rays resulting from electrical discharges in a highly thin gaseous lead to the discovery of electron when an electrical discharge is passed through a tube containing a gas at a very low pressure. An invisible stream of rays called as cathode rays is emitted from the surface of cathode. Cathode rays are emitted in the surface of cathode, which possess a certain characteristic suggesting that the rays are made up of a minute negative particle, and that particle are called as electron, according to discovery of electron given by Sir J.J. Thomson, or cathode rays tube. Next, history of the atom. Rutherford atomic model. Rutherford was the first person to bombard atom artificially to produce a transmuted element. The modern view of nuclear atom is based on the experiment of Rutherford. What is the experiment of Rutherford? What is the Rutherford atomic model that we will study? Rutherford experiment. It is an Rutherford experiment. Source of alpha particle, beam of alpha particle, some particle are scattered, screen to detect scattered alpha particle. Most of particle pass straight through the foil and thin metal foil. It is a Rutherford experiment there is a setup of Rutherford experiment, or it is a source box, then it is a metal plate, it is gold foil. When experiment during the experiment or the Rutherford atomic model, the model view of a nuclear atom is based on the experiment of Rutherford on the scattering of alpha particle by a thin metal sheet. That is, alpha particle are actually double charged helium ion emitted from the radioactive substances during the decay. When beam of alpha particle from the radium C were passed through a thin sheet, that is 0.0004 centimeter of metal like gold, copper and platinum or silver. Majority of alpha particle continue their straight path. Majority of alpha particle continue their straight path. Some were scattered through the larger angle, but some are very few were even back. Some are very few, those are even back, as if they had collided with a heavy stationary object and suffer a deflection of a nearly 180 degree, that is shown in figure. Deflected means to change their path, to change their direction. It's a Rutherford experiment. Rutherford scattering. In 1909, Rutherford undertook a series of experiments. He fired a alpha particle at a very thin of a gold foil. That is, he fired alpha particle on a very thin gold foil. According to Thomson model, the alpha particle would only be slightly deflected. Rutherford discovered that they were deflected through large angle and could even be reflected straight back to the source. Rutherford undertook a series of experiments. He fired or bombarded alpha particle to a thin plate, gold plate, where some alpha particle are straight possess a they are some alpha particle, those can't change their direction, but some alpha particle, they were deflected through the large angle, and some were reflected straight back to the sources. Here alpha particle, suppose Rutherford undertook a series of experiments. He bombarded alpha particle at very thin gold foil. According to the Thomson model, the alpha particle would only be slightly deflected, but Rutherford discovered that they were deflected through the large angle and some are reflected straight back to the source. Next, Rutherford apparatus. Beam of alpha particle, it is an source of particle radioactive substance, that is radium C, and circular coated fluorescent screen, then gold foil. It is an what Rutherford used, that is Rutherford apparatus. Rutherford apparatus contain radioactive substance or radioactive box, it having radioactive substance, gold foil covered by the fluorescence coated skin. Next, what Rutherford expect the alpha particle to pass through the without changing very much, changing a path. Actually, he expected the alpha particle that he bombarded on the gold foil, they pass through the gold foil without changing of the path, because the positive charge were spread out evenly along, they were not enough to stop alpha particles. The predicted result and observed result, he expect, that is seen in diagram, he expect path, that is straight line, that is emitted alpha or bombarded alpha rays on a foil. He expect a path, that is a straight line expected on a screen, and he actually he observe result that is given in the structure or given in the diagram. Next, he observed after the experiment, he observed the most of alpha particle pass through the foil as undeflected. Right? The most of alpha particle pass through the foil is undeflected. Some alpha particle are deflected slightly as they penetrate the foil. Third one, a few are generally greatly deflected. Fourth, a similar small number do not penetrate the foil at all but are deflected back toward the source. What Rutherford observed when Rutherford bombarded a alpha rays on a thin foil of gold, he observed that some alpha particle pass through the foil. They cannot deflected, means they cannot change their path. They cannot change their direction. Second observation of Rutherford, that is some alpha particles are deflected, means or slightly deflected, means they slightly change their direction, and some of are greatly deflected as a similar small number do not penetrate the foil at all but they are deflected back toward the source. There is main four observation, that is the most alpha particle pass through the foil or gold foil. Second one, some alpha particle is slightly deflected, some are greatly deflected, and some are deflected back toward the source. Next, Rutherford then depend on the observation, that main four observation, Rutherford interpretation is he interpret an alpha particle pass through the atom are undeflected, an alpha particle is deflected slightly as it passes near an electron. Third one, an alpha particle is strongly deflected by passing close to atomic nucleus. An alpha particle bounce back as it approaches the nucleus head on. The interpretation of Rutherford was they interpret, that is an alpha particle pass through the atom, those alpha particle are passed through the atom are undeflected, means they cannot change their path. Then another alpha particle is deflected, slightly deflected as it passes near to the nucleus, near to the electron. Then strongly deflected are closely passing through atomic nucleus, and those are bounce back. It is approach that they are nucleus head on. Next, Rutherford, thus the experiment suggests that the atoms consist of an extremely minute or tiny nucleus carrying a positive charge, and that the mass of the atom must be concentrated in a nucleus. Rutherford, thus the experiment suggests that the atom consists of an extremely minute or tiny nucleus carrying a positive charge, and that the mass of the atom must be concentrated in the nucleus. Since the atom as a whole is a electrically neutral, Rutherford calculate the positive charge present in each element and concluded that the positive charge is approximately equal to half of the atomic weight of the element concerned. What Rutherford theories say, when Rutherford do the experiment, he took a alpha emitting source, and what Rutherford say, he took Rutherford experiment, he took a alpha source of a alpha particle. He bombard a alpha particle on coated foil, gold foil coated by the gold foil coated by the fluorescence material. When he bombard alpha rays on a gold thin foil, he observed the some alpha particle are passed through the foil, means they are undeflected, see in the diagram, and some are slightly deflected and some are greatly deflected, but some are reversed back to the source. The rays, alpha rays, are reversed back to the source. He observed in the during the experiment, and then he interpret the an alpha particle passes through the atom. Some are undeflected, and alpha particle is deflected slightly as it passes near an electron. Then alpha particle, those are strongly deflected by passing close to the atomic nucleus, and alpha particle bounce back as it approaches the nucleus head. So Rutherford thus experiment suggests that the atom consists of an extremely minute or tiny nucleus carrying positive charge, that is proton, and that the mass of the atom must be considered in the nucleus. It's all about a Rutherford theories. Rutherford theories, their observation, their interpretation. There is some limitation of Rutherford theory that we will study in a next lecture.